Hello and welcome back. We now look at how we can use functions to structure our code. At least in principle, we can write code by adding more and more statements one after the other. For some extent, this might work well, but it would have some disadvantages, of course. The code becomes very long very quickly and resembles spaghetti code where we just sort of go through everything, and it's basically an entangled mess. You would also have to keep track of a lot of variables because each variable is valid all the time. And the only way to reuse some code is to copy and paste it. It sort of works, and admittedly many people do this, but it's neither nice nor is it efficient, readable, or maintainable. So one way to structure the code is to use functions. Essentially, they assign a block of code with a name, and then we can use this to call a function. The general structure is the following. We use the keyword def to indicate that we define a function. Then we give it a name, say myfunc or something else, open bracket, and then some arguments, which are optional, closing bracket, colon. And note the indent, that everything that is below the indent belongs to this function, and then we may have a return value, or this is optional. We can simply not have a return value and omit the statements. We can also have more than one return value and return some of the variables that we calculate. So we notice the following. The function is defined using the keyword def. It has a specific name. We can pass arguments, and we may or may not use return values. Some programming language distinguish between functions that return a value or not, and Python we just call them all functions. So let's start with the simplest function that we can possibly think of and just have a print statement. We don't have any return values and we don't have any arguments or anything else. We just say we define a new function that says hello, and we still need the brackets to indicate this is a function and have just one line indent. And then we can call this function and it prints it. That's most likely not the most useful function we can think of, but we can see how it works in principle. As a best practice, functions should only do one thing. Make them as short as you can, make them as concise and efficiently as possible. This also has the advantage that it makes it easier to test them, because we want to know what we expect as an output, and this makes it more maintainable. Remember that there is a small overhead in calling the function, but it is very small compared to writing inefficient and lengthy and messy code. So don't hesitate to put even a single line into a function if it helps to improve the code readability and maintainability. Now let's extend our function with arguments. We can have one or more arguments that we pass when calling the function. So say we have the function called mySum. We use the keyword def again to define the function and use two arguments x and y, and now we also have a return value which is the sum of them. So we have a variable assignment, sum equals, and now the return value of my function here. Note that my IDE already recognizes that we don't have types. Remember that in Python, types are assigned on the fly. So x and y are any and returns to n. We can also then print this, and the output is 7. We can make use of the argument in several ways. Above we just pass the numbers and we sort of assume that x equals 3 and y equals 4, because this is the way we put them in the order. We can also do this more explicitly. We can have the same function and now use the print statement again and print out the values before we return the numbers. So if we execute this, the sum is 7, and note that here we don't rely on the order, but we explicitly assign y equals 4 and x equals 3, but then the order doesn't matter. You can also define default arguments, that is, a value that is used when we don't specify the variable. So we can say x equals 3 and y equals 4, and then if we call this function without any arguments, then these default arguments are used. We can use sum of 1. Then we would assume that x equals 3 and y. That this is overwritten and y remains. Or we can use 2 values, or we can have x, or we can have both of them. Right? And depending on the sum function behaves, taking the default values into account. There are also admittedly very few use cases where you don't know how many arguments a user will pass. In some situations this might be necessary. But we can do this by preceding the variable name or the single star. These are often abbreviated because we want to, for example, pass command line arguments so we don't know what they are. So this is why it's often encountered in *args. Or we can use this, for example, and say print pets and then *args, and then it just prints it. And then we can use, for example, many of them, and it just prints this. Sometimes we also may want to pass a function with an arbitrary number of arguments, and we also don't know what these are going to be. This is what we use the ** construct for. For example, update user profile, the name of the profile, and then any number of arguments. This can become very handy in certain situations, and we need to think carefully what we want to do here. So, for example, we can update the user profile. We say we add this to our profile. Functions can have local variables. These are only defined within the scope of the function as indicated by the indent here. So within a function I equals 0 is initialized here, and outside the function this is not now. So if we, for example, uncomment this line, and then this will fail because inside the function I is known, but outside is not. So this also helps to make our code better, because we can have variables in the context where we need them and remove them or not have them outside the scope. As a best practice, when defining a function, we should not rely on global variables outside the scope of this function. Instead, all variables that we need inside should be passed as arguments, and all variables that are needed outside should be part of the return statement. Right? So the following is not a good idea. It will work, but it's very prone to failure. We could have defined sum 0, x and y equals 3 and 7, and then say our stupid sum would be that we have the global sum indicated by the keyword global here, and then use x and y. This will work, but obviously this is a bad idea, because if we change any of these outside the function, then this function may behave very unexpectedly. Now, as an exercise, rewrite the Fibonacci series as a function. The input should be the number of the Fibonacci numbers we want to generate, and the output should be a list containing the Fibonacci numbers, and then call your function and have it return the first 10 Fibonacci numbers. And then again, you can print it, and the output should be a list like this. You can also do functions within functions. Sometimes that may be useful. You have to see if your current need has this requirement, but you can perfectly well do this. You can have a function, let's call it my function, with the arguments as we've done before, and then in the indented loop you can have an inner function or multiple inner functions. Right? So if you have one indent level here, and then we have another indent level here, and everything that is indented here belongs to this inner function or to this inner function, and everything that is on this level belongs to the function my function here. One of the convenience functions that we often use are lambda functions. They are sort of small, anonymous functions. They can take any number of arguments, but only have one expression, and this is what makes them useful, so we can have a very compact way of writing small functions. The term anonymous means here that we effectively define a function as we did before, but we don't use a name for it, but call it directly. So the general syntax is lambda to indicate the special kind of function, argument expression. So this can help us to write more compact code, For example, we can write our sum that we've used before, sum lambda x and y. So these are the arguments of the function, colon, and then what's going to be happening to these. So we have x plus y, and we implicitly have a return value as well. So then we can have the same thing as we did before in one statement. You can also define recursive functions, right? So far, we've encountered the functions when we call them, for example, outside a loop or from other functions, but we can also call the same function within itself, and this is what's called a recursive function. However, the key thing about recursive functions is to define a suitable stopping criteria at which the function no longer calls itself. Right? You can imagine that if the function calls itself and we don't have a suitable stopping criteria, it will go on indefinitely. As an exercise, rewrite a Fibonacci series as a recursive function, or as a second exercise, also use this to write a lambda.